Live streaming is on.
Okay, guys, welcome to Science Today. Today we're going to go over the scientific method, and this is important because whenever I look at one of the task tests, the scientific method is usually on there. So we're going to do, it's going to be a couple days, but I want to just get started on what the scientific method is, okay? So scientific method is something that scientists or us use to try to figure out kind of a problem, and there's steps that go along with it. And what I want to do is I want to look at the steps today when we're doing the scientific method, and we've done this in class a couple times. And the example I use is, say you were on your way to school today or work or wherever you were going, you had an appointment, and your car wouldn't start. So you have to figure out what's wrong with your car before you can get to your appointment. And how we do that is a process called the scientific method. Okay. So the first step, if we look up here, the first step is the observation step. If you see right in the middle of the page, it's the scientific method, step 1, observation. Okay, so it says the first part or step in the scientific method is observation. It says it's curiosity that breeds new knowledge. The process of observation, sometimes called defining the question, is simple. You observe something you can't readily explain with your existing knowledge. You observe some phenomenon that's explained by existing knowledge, but which may have another explanation. The question is, how do you explain that phenomenon? What causes it to occur? So basically, you went out, tried to start your car, and your car wouldn't start. So that's your observation, is my car won't start. And there could be several reasons why it wouldn't start. Now we're going to kind of, dig a little bit deeper. But step 1 is just your observation. Okay. So step 2 is the research. Now we're going to research why my car won't start. So research the existing knowledge about the question. Suppose you observe your car won't start. The question is, why won't it start? You may have some knowledge about cars. You'll tap in that and try to figure it out. You may also consult your owner's manual or look online about the problem. You may even ask friends about the problem. If you were a scientist trying to figure out some strange phenomenon, you could consult scientific journals, which publish research other scientists have already done. You want to read as much about the question as possible because the question may have already been answered, or you may find information that will help you form your hypothesis. Okay. So your research is, you guys know probably a little bit about cars, so you know it won't start. So I guess you're probably going to say, does it have gas in it? Okay, maybe. Is the battery dead? Or maybe my next thing would be, is the alternator not working? But you're going to research why cars won't start. And most of us have some general knowledge. And it said in here, maybe you can go online, maybe you can look at the owner's manual. So that's kind of your research. So our first step is observation, and the second step is research. Okay. So the third step is, it says form your hypothesis. So it says the third step of the scientific method is to create a hypothesis. A hypothesis is a possible explanation for the phenomenon you observed. It's more than a guess, though, because it's based upon thorough review of existing knowledge of the subject. It's basically an educated guess that can be tested. The hypothesis should pose or assume a cause-effect relationship. For example, my car won't start because I'm out of gas. It should suggest one possible cause for the effect, and it should be something you can test and what you can use to make predictions. You can put gas in your car to test out the gas hypothesis, and you can predict that if the hypothesis is correct, your car will start once you add gas. Stating like the effect like a fact is more like a real hypothesis. For those who are still stuck in the if and then statement, if I try to start my car, it doesn't, then it's out of gas. So your third part, the hypothesis, is you're making, kind of like it said, an educated guess on why my car won't start. And I think most of us would, maybe start with, it's out of gas, the battery's dead, or maybe the alternator isn't turning the car over. Okay, so we're going to go, for argument's sake, our hypothesis is going to be it's not starting because it's out of gas. Okay, in the fourth step, we're going to test this out. We're going to test our hypothesis out. So what we do, we put gas in our car. That's testing it. So this says, test your experiment, your hypothesis. Once you've created a hypothesis, the next or fourth step is to test it. Design an experiment that will either confirm or fail to confirm your hypothesis. The experiment should be designed to try to isolate the phenomenon and the opposed cause. In other words, it should be controlled. Going back to our simple car question, we can test our hypothesis by putting gas in the car. But if we put gas in the car and change the fuel filter, we can't know for sure whether the lack of gas or filter was a problem. For a complex question, there will be hundreds of thousands of potential causes. It can be difficult to isolate them in any single experiment. So we want to just put gas in the car because that's what we want to do. We want to keep it to one simple thing. We don't want to do 3 or 4 things because then we're not going to be isolated what the problem is. So we're basically just saying here, we think it's out of gas. So the only thing we're going to do is put gas in the car, okay? And then it says keep records. It says experiments must be reproducible. This is for more like a scientific. If we were in a science class, like Lauren might be able to speak this. If they're doing an experiment, it's important to write down all your steps and keep records. Just for example, like I think I've used this before, like if you were researching like some sort of cancer treatment, you're not keeping specific records. Then when you go to put all this down, if your records aren't accurate, you might not be sure about whatever, maybe the drug you are using, if it basically was beneficial to cancer patients. If you're not keeping accurate records, sometimes you're doing scientific research, sometimes they're probably not going to look at your basically experiment because they're going to say, hey, you didn't have real accurate records. We can't be sure if it's that specific drug. In this case, we're just doing a basic one. So what you would do, but it's important if you took it to a mechanic to say, he's going to ask, what did you try? And if you said, well, I thought I was out of gas and I put gas in there, that's fine. That's keeping basically records. If you just say, I don't know, he's not going to know where to start. That's why it's really important to keep, kind of records or just jot down what you've done, okay? So after we test the hypothesis, the next step is, it says analyze your results and draw conclusions. Okay. And this is hypothesis testing is a simple way to collect data that'll help either confirm or fail to confirm your hypothesis. If your car starts when you add gas, your analysis is pretty simple. Your hypothesis was confirmed. And that says in more complicated tests, you may not be able to figure out whether your hypothesis confirmed without first spending considerable time looking at the data you gather in your hypothesis testing. Note that you do not prove or disprove a hypothesis, but rather confirm or fail to confirm it. The question is why your car won't start. Confirming the hypothesis, you're out of gas. And proving it's pretty much the same thing. But sometimes for more complex questions that may have possible explanations, 1 or 2 experiments cannot prove or disprove a hypothesis. We're doing a real simple experiment here, is what all that's saying. Sometimes you might do several different tests. But for this one, your hypothesis was it was out of gas. You put gas in there, and it started. So pretty much, for the most part, you pretty much answered your basically question. It was out of gas. So you would just, basically, then if your car didn't work again and you went to the mechanic, but you had the results, you're like, well, I thought I was out of gas. I put gas in it, and it started. Okay. So I thought I solved the problem. But maybe you find out later it's something else, but at least by basically writing down all your results, when you do take it to the mechanic, you can basically throw out that it's gasoline isn't the issue, okay? And the last part here, it says report your findings. And this is what you would do more if you were in like a biology or chemistry class and you're doing an experiment. So what you would do here is, basically how you report this is, I walked out to my car, it wouldn't start. I did some research on why my car wouldn't start. I found out maybe it was possibly the battery, the alternator, or was out of gasoline. Okay, so then I created a hypothesis of I don't think my car is starting because it is out of gasoline. Then I tested that hypothesis by putting gasoline in there, and it started. So then you would say from my basically analysis, I thought my car was out of gas and it wouldn't start, and I confirmed that by putting gas in there, and it started. So that would be what it means by reporting your findings. Okay, so it's basically you guys just did a mini science experiment all around your car not starting. Okay, so I want to go down to.
I'm just going to piggyback real quick.
Okay.
So basically, the scientific method is something that you can use in your everyday life, not just with your car, just with anything. It's a list of steps that are created to help you solve a problem, and not just science, but it also works in science. It works in your everyday life, and it just helps create a more organized plan when trying to get an answer to a problem.
Yeah, Lauren made a very good point. Sometimes you might use the scientific method in like math or something where you're just basically knowing it's not this answer because it can't be. So I'm going to cross that one out like on a multiple choice question. Or in social studies or something, well, I know that in the Civil War it was the North and the South. So if there's a question about the West, you're like, well, there wasn't a side of the West. So that's not true. It's almost like deductive reasoning, you guys. You're just going through a process and eliminating certain things that you know aren't true. So obviously, like if you put gasoline in your car and it started and your hypothesis was the battery was dead, you would get rid of that because it had nothing to do with the battery. My car wouldn't start based on gasoline. So it's just something that comes in very handy, that basically you can use, like she said, in everyday applications. So what I want to show you guys is I'm going to skip variables, but variables will come back to these. Okay. So this is just a scientific method, step 1, step 2, step 3, step 4, step 5, step 6 that we just covered. So you certainly can fill this out if you wanted to. Then it's got variables. We'll talk about those at a later date. And what I'm going to do, you guys, is there's a video that talks about how to remember what the scientific method was. So if you look at this, the first one is observation. Then it's like the question mark. You research the knowledge, your hypothesis, your experiment, your analysis, and your conclusion. And then you tell it. So what I'm going to do is I'll show you the video here. And some of you may have seen this. So I'm going to post this in the classroom. I want you guys to watch this, and I'll show you a little bit of it.
I can't hear the sound. I don't know if that's...
Yeah, you guys, I'm sorry. You might not be able to hear the sound, but this guy, it's 4 minutes long, and it just takes you through the steps of doing the scientific method, just so you get familiar with it, okay? So I will go ahead and post that. You can go ahead and watch this, and then we will continue to talk about scientific method, because we'll get into some variables probably on Thursday, okay? So I'm going to do social studies here starting at 11 o'clock, but I'll go ahead and post this video and today's lesson in Google Classroom. All right, you guys, if I don't see you for sources, have a wonderful day. Bye.
Bye.